So as we discussed before, that the summation of latitude and departure must be equal to zero. And if it is not equal to zero, then it means that when you close a loop, the the points, the first point, or when you complete the loop, the last line does not intersect the first point. So the distance by which it fails to intersect is the error in your closure. And if you draw, if AA dash is the distance by which it failed to close, and if you draw its orthographic projections giving latitude in the north-south and departure in the east-west. So basically, if you had this much more or less latitude and this much more or less departure, then the figure would have closed. And the total misclosure distance, it is given by under root squared latitude error and squared departure square and their summation. So that is your total missed closure distance. Now, let's see the whole process again. That the first step is that you have to find out the latitude and departure. And if the Theodolite traverse is not plotted according to interior angles or bearings, uh, that means that it must be plotted according to azimuths. If it is not, if it is done in bearings, you can still use this method. If it is plotted by interior angles, you can still use that method by first calculating the azimuths or bearings, or setting one direction as reference and then taking all the angles in reference to the same direction, same reference direction. So it will work. Then you plot the traverse by computing latitudes and departures, and then you see if the summation of latitudes and departures is zero or not, and then you apply the corrections, and then you balance the traverse. You balance the error to all the survey lines, usually based on their distances or based on the lengths of the lines. So for that, we'll use two new terms, independent coordinates and consecutive coordinates, and I'll get to that in just a bit. But first, let's see the sign convention once again. So latitude, as discussed before, is positive in the north and negative in the south. Departure is positive in the east and negative in the west. So combined, you get the sign for latitude and departure. And if you're using azimuths, you get them automatically. If you're using bearings, then you have to apply your own sign with the value. So that means in the north, we usually call the latitudes and departures as northing, southing, easting, westing. Northing means latitude is towards the north and it's positive. Southing means latitude is towards the south and it's negative. Easting means departure is towards the east and it's positive. And westing means departure is towards the west and it's negative. So basically the same sign convention that we saw over here is repeating, but we usually represent northern latitude or southern latitude as northing and southing, eastern departure and western departure as easting and westing. And since the summation is equal to zero, that means the northern latitude has to be equal to southern latitude. So that means sum of northings should be equal to sum of southings, and sum of eastings should be equal to sum of westings. And remember, this is for a closed traverse because it closes up. So whatever distance it covers towards the north, same distance it covers towards the south. Whatever distance you cover towards the east, same distance you cover towards the west. Hence, we get these checks. So now balancing of a traverse, if the summation is not equal to zero, that means you need to compensate for the error or balance it. Balancing means if I take the example of the interior angles, so if the sum of the interior angles is not equal to n minus 2 into 180, so what we did was whatever the error was, we divided it equally in every interior angle, and then the sum becomes equal to n minus 2 into 180. In this case, we'll study different methods of how to balance that error. So the first method that we're studying is the Borek rule, and by this rule, the correction to the latitudes of every side is equal to the length of that side divided by the perimeter of the traverse, which is summation of lengths of all the sides multiplied by the total error in latitude. So that means more the length of a side, more the error is given to that side. Similarly, for departure, length of the side divided by the perimeter of the traverse multiplied by the total error in departure. So this is how this rule works, and the error is compensated. Second, we have the transit rule. According to this rule, the correction to latitude of any side is equal to length of the side divided by the sum of all latitudes multiplied by the total error in latitude. Similarly, for the correction to departure, we have the length of the side divided by the sum of all departures multiplied by the total error in departure. And then we have the third rule. So the Bodic rule and third rule are used more commonly. So in third rule, instead of applying correction to the latitude and departure, we first divide them into northing, southing for the latitude and easting, westing for the departure. And the correction to northing comes as northing of the side divided by the sum of northings multiplied by half the total error in latitude. Similarly, the correction of southing becomes southing of the side divided by the sum of southing multiplied by half the total error in latitude. Similarly for departures. So this is how the three different methods work, and we'll try to use some of them in the questions later on, but you just have to remember their equations. So now let's see this question in which we have a closed traverse A, B, C, D, and this just discusses briefly how this method works. So first, since we are given the lengths of the sides, so 382.24 feet, 472.68, and we are given the bearings. So these are quadrantal bearings, so they are given southeast, southwest. So that means using these signs southwest, northwest, we can ascertain what should be the sign of latitudes and departures. So now, since we have the length and the bearings in our case, we can calculate the latitudes and departures. So first, for the line AB, we have a length of 472.68. So the equation for latitude is length into cost of bearing. So the length is 472.68, and you multiply cost with the bearing which is given for AB, which is 68 degrees 5 minutes and 35 seconds, and you get this value. Now, since it is south, so that means that the latitude value 176.357 should have a negative sign. For departure, same equation, length multiplied by sign into the bearing, and we get this value. Since it is west, so the departure will also get a negative sign. Now for the line BC, for the latitude, we use the length of the side, which is 216.13, multiply cost with bearing 19 degrees 45 minutes, and we get 203.395. And since it is north, so the latitude will be positive. For the departure, length and sign of bearing. Now since this is west, departure will be negative, since departure is negative in the west. So this is how we proceed. We do the same for the line CD and the line DA. Now once we have latitude and departures for all the sides, we can place the values in our table. So over here in the first column we represent the line. So our closed traverse has 4 lines: A, B, B, C, C, D, and D, A. Then we represent the bearings, which are given with every line. So these bearings, and then we are given the lengths of every side as well. So here comes the length, and then when we add up the lengths, we get the total perimeter of the closed traverse. And then we have the columns for the latitudes and departures, and the units for latitudes and departures are also the same as length, because the two are actually orthographic projections of the lengths given with the direction. So the latitudes and departures that we just calculated, along with their relevant signs. So if the latitude is in the north, it will be positive. If it's in the south, it will be negative. If the departure is in the east, it will be positive. If it's in the west, it will be negative. So once we have the latitudes and departures, we take their sum, which should be equal to 0 if the geometrically the closed traverse is plotted correctly. But if after plotting it using latitudes and departures, their summation is not equal to 0, that means there is error in the traverse and it needs balancing. So once we have the error in latitude and the error in departure, we can calculate the total error that the equation that we saw earlier. So the error was called as the total missed closure distance or the total linear closure error, and we had the equation over here. So using the same equation, taking the under root and squaring your total error in latitude and total error in departure along with the sign, so we get the total missed closure error 0.112. So now that we have that, we can actually now balance it, and by balancing I mean changing latitude and departure of every line, so that once you're done with it, sum of latitude becomes equal to 0 and the sum of departure also equal to 0. So now let's see over here. We have this another question in which uh, the survey lines, their bearings, and their lengths are given, and their latitudes and departures we can calculate, or they have given us directly in this question. And what we have to do is we have to balance these latitudes and departures such that the summation of latitude and departure becomes equal to 0. So now in this question, you can yourself calculate or recalculate these latitudes and departures for every line. So for the line AB, we have the bearing given, it's northeast, and the length is given. Length multiplied by cos of this value will give you the latitude. Since it's north, it's positive. Similarly, the length multiplied by the sign of this bearing will give you the departure, and since it's east, it is also positive. So when it's south, the latitude will be negative, and when it's west, the departure will also be negative. And when you take the sum of latitudes and departures, you get negative 0.71 error in latitude and positive 0.53 error in departure. And now we will try to solve it or balance the error using the Boric rule. So what does the Boric rule say? That in order to balance the error, you will use the equation for latitude as length of the side divided by the perimeter of the traverse multiplied by the total error in latitude. So let's try to apply this equation. So for the line AB, we have the length as 285.1. So for applying the correction in latitude, we have the length divided by the perimeter of the traverse. That would be the summation of all these lengths multiplied by the total error in latitude, which is negative 0.71. So if we do this for every side, so in our equation, the only thing that would be changing would be the length, because the perimeter is the other uh, constant in the equation. So that would remain the same for every side, the perimeter of the traverse. And then we have the total error in latitude that also remains the same. Similarly, for departure, the equation becomes length of the side divided by the perimeter of the traverse multiplied by the total error in departure. So for every line, the length would be different, the perimeter of the traverse would be the same, and the total error in departure would also be the same. So once we do that, we have positive corrections in latitude for every side and negative corrections for departure in every side. This is because our error in latitude is negative, so we need to have positive correction in every line so that this becomes equal to 0, and we have a positive error in departure, so we need to subtract something from every line so that this becomes the summation becomes equal to 0. So that is why every correction in latitude is positive, in every correction in departure is negative. And once you add up these corrections along with the relevant signs of correction and relevant sign of the latitude departure themselves, uh, you get balanced latitudes and departures. And then when you take the sum, now the summation is equal to 0. So that means these are the correct latitudes and departures, and using these correct latitudes and departures, we can redraw the traverse and see what difference it makes in other measurements. So this is how we proceed in order to balance the whole traverse. So in summary, what we have done is that initially we try to balance the angles. That means before using the latitude and departure procedure, it's recommended that first you take the sum of the interior angles or the sum of the exterior angles and see if it is equal to the standard value for whatever the side of the traverse is. And if it's not, then you balance the angles. So whatever the error is, you uh, balance it equally in every angle. So that's the first step. Now, once you're done with that, you compute the bearings or azimuths. So, like told you that you could either be working with bearings and azimuths from the beginning, or you could be working with angles. You could convert those angles into bearings or azimuths, or you can set one direction as your reference direction and calculate all the other angles in reference to that reference direction. So in our questions, we'll be working with directly azimuths and bearings, so they'll be given to you. And once you have that, you can compute latitudes and departures. Then we can calculate the total linear error of closure by the equation that we discussed before, and we can compute the precision ratio of the survey. So this basically tells you that depending on how big your traverse is, what is the total error in your traverse. So precision ratio is given by E over P, where E is a total error in closure, which is given by under root the error in latitude squared plus error in departure squared, and P is the perimeter of the traverse. So this means smaller the precision ratio, the better, because the smaller means we have a smaller error and a larger perimeter. So that means in a bigger traverse you have smaller error, and bigger the precision ratio, that means there is more error and it needs more balance. So let's see one more question in which we have a closed traverse A, B, C, D, E, and we have these five sides A, B, B, C, C, D, D, E, and E, A. For all the sides, distance is given. So if you add up all the distances, you get the parameter. The bearings for all the lines are given in terms of the quadrantal bearings. So we have the directions in terms of northeast and southwest given as well, and you can either convert them into azimuths if you want. So we've done this a lot of times before, or you can work with the bearings, and then we can calculate the latitudes and departures. So the latitudes would be the distance times the cos of this value or this value, and the departures would be the length, the distance given, multiplied by the sine of this value or this value. If you're using azimuths, the signs would come in automatically. If you're using bearings, then depending on if it's north or south, the latitude would be positive or negative, and if it is east, the departure would be positive, and if it's west, the departure would be negative. Then you take the summation is not equal to zero, and usually that is the case whenever we're working with closed traverses, and usually we have to balance it. So these are the errors that we get. So in order to get the total disclosure error, you take their squares, add them, take the under root, and you get a total disclosure error divided by the perimeter, which is the summation of the distances, and we get the precision ratio, E over P, and it is in fraction. So once we have these, now what we need to do is we need to balance the traverse. So before I move on to balancing the traverse, I'll talk about um, consecutive coordinates or independent coordinates. So I'll use this figure. So basically in consecutive coordinates, we use the values of latitudes and departures that we get from our equations directly. But in independent coordinate system, you basically what you do is you draw the traverse somewhere and then you take the origin at some distance. So that means if the origin is now over here, so this is coordinate 0, 0. Whatever reference point you take, in our question they took the reference point as A, and at A the coordinates are 1000, 1000. Now, since the latitudes and departures give us coordinates, uh, whatever difference you get in the next point's coordinates, you add or subtract it from the coordinate of the previous point. So, if A was at 1000, 1000, and the value of latitude is 53.16. So the coordinate of B would get 1000 plus 53.16. Similarly, for the departure, if it was 1000 over here, it would be 1000 plus this value at the point B. So this is the beauty of it, since we were working with orthographic projections. So that is basically the change in y dimension and change along the x dimension. So this is working with independent coordinates where you use the reference at some distance and you give one of the points reference coordinates, whatever the distance is from the origin, and using that you keep on adding the latitudes and departures. So now let's say we are at point B, and now for point B we have latitudes and departures, and then we calculate the latitudes and departures for the line BC. And the departure is, since it's in east, plus 45.55, and the departure, since it's in south, it's negative. So for latitude, you subtract it from the latitude value or the coordinates at B, and you get the new latitude for C. And for the departure, since it is towards the east, you add it in the departure for B, and you get the departure for the point C. So since we do the grid over here, so we have the origins over here. So north, east, north, south, east, and west. So same thing is working over here. And when you complete the whole loop, when you do line EA, the same process in the coordinates of the point E, you calculate the coordinates, latitudes and departures for the line EA. Then you add them or subtract them in the coordinates of E. When you do that, you should be left with 1000 and 1000. If you're left with that, that means the whole work was correct. If not, then it means there is some error. Previously, we were doing it with the summation of latitudes and departures. They should be equal to 0. The other way is to use independent coordinates and proceed in this way. Now let's see this table. Using consecutive coordinates like we did before, the summation should be equal to 0. But if you are using independent coordinates, so that means the coordinates point A are 1000 and 1000. And like we just discussed in the figure below, this is just the same thing in tabular form. So when you close the whole loop and come back to the point A, you should be left with 1000 and 1000. And if you're not left with that, that means whatever the difference is, that is the error. And then you can work with that to balance the whole traverse. So now let's see this problem. We have a closed traverse and we have 5 lines. The lengths are given and the latitudes and departures are already given. So you don't have to calculate them. You just have to see if this closed traverse needs balancing, and if it does need balancing, you need to apply the Boric rule and the third rule to balance them, and see that when you find out corrected latitudes and departures, if the summation is equal to 0 or not. So try to solve this, and we discuss the same problem in the class.